Hello, everybody. My name is Oleksandr, and I'm a software engineer working right now in Playtica. And today I'm going to talk about what is contract testing and where it suits and where it's applicable in the modern testing world, and how to do it using Spring Cloud Contract tool. Basically, my talk actually will be like a little bit continuation on the topic of backend testing because contract testing it's mostly related to the backend. So for now, no UI, unfortunately, involvement. So let's start. So first of all, what I want to say about testing at all, that from my point of view, testing is not easy, testing is hard. And testing for when you perform testing of just a simple web application, it is not so hard, but like moderately. But if you are talking about the big systems, testing can be hard, and we as testers, as software engineers, we need to apply a lot of different tools and techniques in order to ensure that we produce application and produce systems with enough level of quality. So basically, what we actually get used to through the modern uh, 20 years or so, it's when we are working with applications based on the monolithic architecture. So what is it? It's the way how the backend of the system is constructed. So we have on the backend, we have on the server or on a number of servers, a huge big application, backend application with some API that we can call. We as testers can call it in order to verify it from functional or from performance point of view, but also UI part of the application can also make a request to this big, huge pile of code, for example, from the mobile application or from the web, and get the results that it is needed. But as the application complexity grows, like for the last 10 years or maybe a little less, a lot of new products or a lot of existing products are rewritten using another like approach to the construction of backend. It's microservices. So what the main idea here is that instead of big huge amount of like monolithic backend that which serves all of the requests, we have a lot of little services which each of these services do one or one main thing. So it has a strict functionality, and all of these services on the backend are communicated. The communication can be using the regular API calls like HTTP calls, or it can be also using any kind of messaging, for example, using such system like Apache Kafka or RabbitMQ or any other message broker. So the main idea and main advantage here that right now microservices provide you with a lot of flexibility in deploying your changes to production. Because if we are talking about the monolithic applications, if we want to deploy it to production, we need to deploy everything. If we are talking about microservices, we can deploy each microservice independently. So the release rate actually can be a lot bigger than in monolithic. So let's go through the strict example. So in my presentation, there will be a lot of code, using Java because it's my main programming language, but it can be like rewritten in other languages. So basically, imagine the situation that we need to test the new functionality of our application from the backend side. So we have two services which communicates with each other. The first one is user service, and the second one is bonus service. And we need to verify that new functionality, which involves actually executing GET request from user service to bonus service, actually works. works as expected. So underneath, the piece of functionality that we are testing is performing the request to the bonus service and to the user balance endpoint and passing some parameters like user ID and session ID. And then the bonus service returns a result and we need to verify it. So if we are talking about testing at all, like from what we can test, and I assume that by we, I assume that we as a team, so it involves testers, developers, designers, or whatever. So the team. But first of all, developer can write the unit test. The unit test actually will mock everything related to the bonus service and substitute it with like self-implemented piece of code. And we, where in unit testing, we are actually concentrating only on verifying that the code on the user service works as expected. As you can see, we have a piece of code that performs mocking. It's when we execute get user balance request, and then we should return like a pre-configured value here. And then we asserting that this user item is equal to 100. So the first and the main idea here is that unit tests can be written very easily, and they run locally, and they are executing really, really fast. So actually, in a matter of minutes, you can execute like hundreds or thousands of unit tests. So the feedback rate, so the feedback if everything or anything is broken, is really fast. But we have a really interesting thing here. So imagine that we have covered all of the interactions between user service and bonus service on the unit level. So we have like 100 of tests that are passing, that are green, and then we deployed to our change to some environment, real environment, and then start test not with substitution, but start testing the communication, real communication between user and the bonus service. And it perhaps that the integration between the services is broken, because while we have implement the unit test on the user service, assuming that bonus will respond like 100 and this like integer value or whatever, in fact, the bonus service developers can change everything, can change any API, can change any value or any format, and then deploy an updated version also to the testing environment. And then we have a integration issue. In the end, unit tests provide quick result, quick value, but they do not provide any like real result. So what's happening right now with this communication? So basically, if we want to avoid this kind of issue and prevent it, we can write an API test. So the API tests perform a real call from user service to the bonus service, the real execution of the get method, and perform what actually bonus service will respond. So the main idea here is the API test, or an end-to-end API test, is performing on some environment. So you need to deploy one service to environment, you need to deploy second service in environment to the same environment, and then perform the request and assert the response. But in some cases, if you are talking about microservices, in some cases, the deployment of user service and bonus service will be enough for testing. But in some cases, you need to deploy some other services, because, for example, if you need to test a little bit more complicated flow, you need to deploy more services, or you need to deploy the whole backend on the environment before starting a simple test, simple like request response test. So here we have a real result, so how the services behaves for real, but we need time, we need to spend time on deploying all of these services to some environment, and we need to spend time on actually executing such tests, because comparing the unit test and API test on the real environment, we can have a result or feedback from our automated tests in a matter of minutes or maybe 10 minutes or so. So it's really, really slow comparing to unit tests. So what we need or what we should choose cover all of the functionality from unit test level or from the API test level. And maybe there is something in between. And basically we have something in between. We have construct tests. So basically, if we are talking about construct tests, we always talk about the two sides. The first side, which perform request, is called in the terminology of contract testing, it's called consumer. And the side which respond with some data, with some value, is called a producer. So in contract testing, instead of writing a tests, we first write a contract. It's a definition of what user service, in our particular case, what user service expect to from bonus service when there will be a request to the user balance endpoint with such parameters. So I, as a user service, expect that the response will contain this, 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 and this. And then based on this contract, will be they should be written tests on the user service side, like contract tests, and the test on the producer side. And the main advantage here about contract testing is, first of all, contract tests, when the whole pipeline is implemented, the contract tests are executed locally. And they are executed a little bit slower than unit tests. So it's really, really fast. They provide a fast feedback. But from other point of view, the contract tests provide a real value. So the contract defines how the services behaves and communicates right now. So if any counterparty, so in our case, if user service or the bonus service want to change something, change the integration between these services, they need to update the contract. And then if they update the contract, immediately all of the developers that involves this contract will get the results, will get the failed tests. Hey, you as a developer or you as a test engineer should take care about the broken integration. So you need to write code that will resolve the issue, the integration issue, and you should update your consumer test or the producer test. So basically, here is the comparison of these three types of tests that can be applied to microservices. It's unit, contract, and API. And as you can see from the contract tests, we have a fast feedback. We have change tolerance. So if anything is changed on any side, we get a fast feedback. And also the contract tests, as for API tests, they assume that the teams which implements all of these services need to communicate a lot, because without the communication, the contract tests actually cannot be implemented in a more proper way. Okay, so a little bit deep dive into contract testing. So basically, there are two main approaches in contract testing that you can implement. The first is producer driven. The main idea here is the producer defines all of the contracts for each of endpoint that there exists. And in our case, bonus service implement the three contracts, and then each consumer which wants to communicate with this bonus service should fulfill this contract. So the producer provide the contract. And the alternative way is consumer driven. So each new consumer which comes to the producer provides the contract. The main advantage comparing these two approaches, the main advantage of consumer driven contract testing is that each consumer can define its own version of contract for the similar or for the same endpoint. For example, if you are talking about our example, the user service creates a contract for user balance endpoint for the bonus service. And some other service creates also the contract for the user balance endpoint. But the main idea here is user service expects that bonus service will return some JSON with some bonuses, and each bonus will have the bonus ID field or property and the bonus type property. And some other service needs only the bonus ID, and some other service doesn't care about the bonus type at all. The main thing here is if from any point the bonus conference service will delete bonus type property from the bonuses, or maybe change the type of bonus type to some integer value or double value or to any kind of value, or just update, rename the property. As a result, we have a broken integration only between user service and bonus service. And the integration between other service and bonus service will not be broken. So this is like the main idea of consumer driven contract testing. So in Java world, we have the main mature tool for implementing contract testing. One of them is Spring Cloud Contract, and the other is Pact. So the Spring Cloud Contract is more tied to the Spring Boot and Spring frameworks. So if you are using Java and the Spring framework, it is more suitable to use the Spring Cloud Contract, but it's not like the Spring Cloud Contract is not limited only to Spring, but it's more easy to integrate with Spring-based projects. But if we are talking about Pact, it's more universal tool because it allows you to implement the contracts and contract tests not only for Java-based languages, but also it has the JavaScript integration, as I know, Python integration, C# integration, and a lot of other integrations. So if you are just thinking about contract testing, you should check out Pact as well. So let's go to the code and to the examples. So here is an example of the Spring Cloud contract, actually the construct between our services like user service and bonus service. There are multiple ways, multiple languages, how you can define the contract. First option that you have is define contract using Groovy language, Groovy domain-specific language. This is example using the Groovy. The other the other option is using the YAML format or the Kotlin DSL. So there are a number of options. But in my talk, I will concentrate only on the Groovy-based. But the idea is the same for any options. So first of all, you are if you are talking about REST communication, like HTTP calls, you need to define request part and the response part. So for request part, you should define that here is a contract for the method get. Then from the consumer, I will make a call. I suppose it will be a call to the bonus conference service / user balance endpoint. And from producer point of view, if you are talking about producer side, it's only the call to the user balance endpoint itself. And we have two query parameters. In our case, it's user ID and the session ID. And you can define it using regular expressions and the hard-coded values. You can choose whatever you want for the contract. And for the response part, we define what we expect. So in our case, we expect, as we expect from any GET request to any endpoint, we expect that the status code will be 200, so the request will be successful. And then we expect that body will be in a JSON format. So we are checking that headers and the content type in the headers will be application JSON. And the body actually will be in the following format. So we will have an array of bonuses, and each of array element will have a bonus ID of the type int, and the bonus type is a type of any string. Basically, the main idea of the contract itself, it's not contract testing. It's not about testing the functionality. It's testing about the format of communication. So one counterparty will expect that there will be a request with such query parameters, with such data types, and the response will be with body using this data type, in our case JSON, and with defined properties. So it's only verifies and concentrate on verifying only the types of body. Okay, so basically here is the whole REST contract, and this is like a summary of what I just explained. So basically, we are concentrating only on the format. And how actually it works underneath, like Spring Cloud contract. Basically, there is a Spring Cloud contract Maven plugin, which runs both on the consumer side and on the producer side. But the main the main work or the execution flow is a little bit different. On the consumer side, we have a part which called contract stub runner, which actually generates based on these contracts that we have defined. It generates stubs and execute it for our test. And on the producer side, it generates the tests and execute it. So how actually the tests will look like on the consumer side and the producer side for our example contract for between user and bonus service. So basically, what's happening more deeply, it's on the consumer side. This part of Spring Cloud contract will go to the separate repository with contracts where you defined your contract. It will download the contract to your local machine. Based on the contract, it will generate a wire mock stub for this endpoint, and then the tests that you are implementing will be executed against this stub. So how it looks like, you define the rule, stub runner rule, in your Java code on the consumer side, where you define where the contracts actually are placed, then which of the exec stub you want to download. In our case, we want to download bonus service stubs. And when we want to execute and run all these stubs on the given port, also we are going to actually use remote repository in this case. And then we just adding from our feature code, we are adding the client for communicating from this bonus service. So the test actually is the simplest one that you can have from the API point of view. So in this particular test, we are concentrating on the executing user bonus balance, getting the results. In our case, the results will be list of bonuses. We asserting that this list of bonuses is not empty, and we get the first bonus. In our case, the list of bonuses will contain only one bonus, and we assert that bonus will get the bonus ID as we expected. In our case, the bonus ID will be like 0, and the bonus type will be any string type that we define. So here is the test from the consumer side, the REST part. On the producer side, there will be like a little bit interesting. Instead of just downloading the contracts and creating stubs for the contract, the Spring Cloud contract downloads the contract and create a test, actually the real test based on the contract. And this generated test will be executed against the bonus service API. The only thing that you, as a developer of such tests, that you need to implement is the providing sample values, return values, when some code will execute your endpoint with such given values. I will show you on the next slide how it's look like. So basically, here is an example of the real test that is generated, automatically generated, based on our contracts that we have described. So as you can see, the framework for running such tests, it's rest assured. I will provide the links after the talk to all of these frameworks that I mentioned. So basically, it actually scans all of the contracts and creates assertions for anything that you place in this contract. In our case, it asserts that the status code is 200, it asserts the content type, and also it asserts that, hey, we need to have a field bonus ID equal to some value and bonus type property with some value. And the only thing that we need to do on the producer side itself is create like a fake response with this expected values. So we are creating on our side, on the producer side, some data type, internal data type user bonus with bonus ID equals to 1 and bonus type equals to expected. And then we define that if any like during this test execution, if any service or any test will execute my endpoint, in our case, user balance endpoint, with defined values like user ID equals 1 and session ID equals 2, then I need to return, as a result, I need to return the expected values. So basically, it will prevent the producer service developer from changing anything, for example, the data format. Because if you change for some reason the data format of bonus ID to some double, you will the tests will be generated based on the contract automatically, and they will expect actually that the type, the type of the variable of bonus ID long, not a double. So you need to, as a developer, you need to go to the contracts, update the contract, and then if when you update the contract, you can update your test code. And the main idea, continuing what's happening after updating the contract, when you update the contract, it will automatically, like the Spring Cloud contract and the system will, which will be based on this library, it will automatically notifies the other part, in our case, the user service developer, about the change. So, hey, we have a change in our communication flow and communication format. Do you agree this change? If agree, please pass the approve this change from your side, and then implement the functionality and the code based on this change. So any if contract testing implemented in a suitable and in a proper way, any type of integration testing can't be done at all, because you are prohibited of making any integration change without approve of other counterparties that you can break. So here is the first thing is about REST tests. Do you have any questions for now? And or we can continue to the messaging part.
Yes, we have some questions.
Yep.
Max is asking about, is it some kind of unit tests that are regenerated each time when you update the contract for two repositories?
Okay, so if you are talking about the producer test, it is a unit test. It's not like a unit test, it's API test. So imagine that you have a simple API test when you have an endpoint and you have a rest assured library and you specify Given I have a request to this endpoint with these parameters, then I asserting this response. So it's like automatically generated API tests, but for the service that is executed locally. So everything, if you're talking about contract testing, everything is executed on your machine. So you are just instantiate a part of your logic that belongs to the request response processing for this particular endpoint, and then you are checking the formats. So you make an internal request and get internal response.
And
And
another
for the
good
concept,
question.
yeah,
Sorry. Another good question. Can we leverage OpenAPI Swagger specification for this kind of testing?
Yes, so there are some implementation of Open API integration with Spring Cloud contracts. So based on your existing Open API, you can generate the contract and then use it as a the contracts and integrate it into your flow. So this is like the main idea. But as for Swagger API, from actually Swagger, it's like only the visualization of the existing and like API of the service or the system. So you have using a couple of annotations, you get the full visualization and interaction with your endpoints. So you can just use Swagger as it is with for generating contracts. Maybe in the future there will be.
And thank you for the answer. And the question from my side, you mentioned that you need to host this contract somewhere in Artifactory. So as far as I understood, this is the main concern for the developers. You need a centralized way to publish these contracts as an artifacts, and each time you run this build, it will be like pulled from the Artifactory and then used as new version of contract, right?
Yes. So using the Spring Cloud contract, there are two main ways how you can deal with contracts as artifacts. The first way, as you have mentioned, it's centralized, the separate centralized repository only for contracts. So for each time, if any service, other service wants to run contract tests, yeah, underneath it makes a call if there to this remote repository, if there are any new updated version of this contracts, and it downloads these artifacts like jar files, and then use it for test generation or stub generation, whatever. The other way how to deal with contracts is to put contracts on the producer side. But in both ways, if you want to change the way of communicating, you need to go somewhere, update the contract, get the approvals, and then only after that you come back to your code change and then proceed with your changing. So there will be a notification of the other counterparty. In our company, we have we research both ways. Of course, there are more hidden things in each way, but in our company we stick to the centralized repository. But the centralized repository of the contracts, if you it's a good thing when you deal with let's say few dozens of contracts or maybe hundreds of contracts. But if you are talking about the contract testing at the scale of the whole company, it can involve, for example, in our case, right now it's more than 1,000 of contracts with a lot of sub modules and a lot of other things. So you need to spend time on technical configuration of such repository, And of course, there is a big thing about performance of such repositories. So right now we are working internally, we are working on optimizing the build time of such repository, because the last thing that we have like almost a little bit of 700 submodules inside of this one project, like the contract test project. And the build time of the whole system was like, or the whole contract take around like 30 minutes. So right now, after
This is
optimization,
the
we take,
time to build the jar with all the
the new
contracts.
version, the new versions of the new versions of the contracts for all of the contracts, for all of the services on the
Build
contract level.
basically the whole repository of contracts.
Yeah. And right now, we have, after optimizations, we spent only like 2 or so minutes on actually regenerating the jars for the whole contracts. And actually, we switch the compilation, all of the compilation process from the centralized repository to the developer machine. So you download only the jars that you needed, and the whole compilation process is performing on your machine. And then after one time, it will be, of course, cached in your local Maven cache, and then you will just use it, and the execution time for the contracts will be decreased.
Okay, got you. Thank you.
Okay, so let's continue to the messaging. So basically, the messaging contracts in the Spring Cloud contracts is almost the same as for REST. The only thing that we need to take care of is the format of the message that we are passing from one side to other side. So the definition of the message is actually in the output message section. So we define which topic do we want to send this message to, and actually the body of the message, the format of the message. So in our case, we are sending, so one service sends to another service to the topic user balance update topic. It sends a message with 3 fields: user ID, session ID, and action. So this is it. After defining the contract itself, we define the consumer test, and the main idea here is on the consumer side. The only thing that we need to define is we are preparing the expected message, like what we expect in our case. Then we execute the part of the Spring Cloud contract that will trigger underneath, that will trigger sending like a fake message to the fake topic. And then we capture it on the consumer side. We are capture this message, and then just field by field, we are comparing that the message that is captured, the message that is actually generated based on the contract, is expected to our right now to our message format. So this is like the main idea of such tests. On the processor side, the underneath, Spring Cloud contract will generate the test for it. So basically there will be a test which performs as sending a fake message to the fake topic and performing actually capture it, and then performing comparison. The thing is to define that on the processor side, to define that if anybody during the test will want to send this fake message to this fake topic that is defined in the contract, then we should return the already prepared message in this prepared format. And then underneath, like during the testing, it will be compared field by field if everything is okay from the format point of view. So the main idea here, and then the main idea that I want to talk about in the end is it a silver bullet, like contract testing and substitution for all of the tests that we have for any system or for any microservices based system? So my answer is no and yes. So if we are talking about microservices, and here is like the example of what we have in terms of automated tests or manual tests for our backend and front end. So basically, we have for each service we have unit tests, and also for each service we have a component test. Then for each service we have a contract test, and then we have an end-to-end UI and API test and a little bit of exploratory testing. So the contract test, as you can see, it's only the part of the testing. But why I mentioned yes or no? So previously I answered only no, so it's not a silver bullet. But the contract testing in our case, when we implement and cover by contract tests, like almost like 80 or 90% of our existing functionality, like legacy code, and when the contract test is set up as a prerequisite for any new change or any new service that is developed, so you can't develop any new service without contract test. So you can't just say, hey, it will be like somewhere in the end of the flow or something like that. So it allows us in some cases the combination between component tests. So the component, by component I mean the tests which test the one service in isolation on the local machine, the whole functionality of the service, and the combination of the component plus contract leads us to decreasing number of end-to-end API tests. End-to-end API tests, it's actually the tests which are executed on environment. So if you have a good coverage of component contract tests, you can, in our case, we actually, it's right now, for us, it's optional to have an end-to-end API test. Before contract tests, we have like a rule that each new functionality should be covered by this type of test, like end-to-end API. So contract tests can decrease the whole amount of tests. And actually, as you may imagine, that end-to-end API or any end-to-end test, the results are really not related. It's really you can predict the results of such tests, because on the environment, when you have like a 300 of microservices with communicated with each other and just executing your tests and functionality, you can't rely that every time your end-to-end test will execute like for 100% correctly. But as we are talking about component and contract tests, you can rely it because it's really stable, and it's fast, and it provides you a fast value on your local machine. So right now we have for each new pull request from for our backend part. So for backend developers, you need to cover new functionality by unit, component, contract test, and you need to have all of these tests for your service fast. Before it, without it, you can't get approved and you can't get your change to the production. So
sorry to interrupt.
Yeah.
And how do you check that this is enforced before merging pull request? Is it automatically, or you just go through the code?
So how it's verified? So basically, as contract test, it's a little bit like a mix of unit and API tests. So basically, we have automatically executing. First, we are generating the code, like a compiled code. Then we have a unit test executed. Then the next step is contract test executed. All of the contract tests for this particular service. Then we have all of the component tests executed for this particular service. It's all can be executed on your local machine or can be executed during your pull request run. And if so the result of the build of the service, like Maven build, if every test is passed correctly, the build will be green. This is the one of the prerequisites for approving your your change to the code. And the second one, of course, is the code review, because if you have any change to the contract, you need to provide the link to the report to contract repository. Hey, here is a change. It is approved by other counterparties. Without it, you can't. You will not get an approve. And also for the new functionality, also other code reviewers will get to you and ask, hey, you have a new functionality, you have a new endpoint, and you do not have any component tests. You should write at least for the happy case, for the like main flow, you need to execute it and create one or more component tests. And of course, we have a sonar cube that scans our code and prevent us from lowering our unit test coverage. So this is like a lot of prerequisites for each pull request and for each code change.
Thank you.
Okay, so the main thing that I want to mention, that we have like establishing the contract testing for 3 years right now, and we continue to progress with it because it brings other challenges. We solve one challenge and then another comes up. So what you should be prepared when you go to the contract testing and you want to implement and start it on your project. First of all, you need to have a technical training for your developers and for your testers. So as you have seen from the slides, the contract test is deeply requires deeply understanding the code, the functional code. So in most cases, it is recommended that contract tests should be implemented by the developers. But we have a lot of examples that after a training, technical training, we have a lot of QA engineers that implements the contracts and contract tests for the services, and there is not so hard if you have enough skills, enough Java skills. So it's not like a Selenium WebDriver, like when you just get like 5 type of calls and you can automate everything. It requires more deep knowledge, but it can be achieved. Also, you need to have a process change. So you need to have you need to sync even before, you need to sync together with your product managers, together with your architects about the flow. So what if we have an urgent fix to the production? It requires the change in the contract, but you are unable to merge it before some other counterparty or some other like 5 other services will get approvals or get your pull request reviewed. So it can take time, of course, but you need to have rules, and you need to, of course, you need to have an exceptions when the fix should be like deployed immediately. But you should, for example, we have a rules that new services should be covered by 100% for the contract tests. All services, it depends on the service, also should be covered by contract tests. And the architects will not approve an initial like service template without a contract test at all. So you're just unable to proceed with your change without contract tests. And also you need to have skills, time, and people to get your technical setup. What I mean by that, if you choose to host all of your artifacts like contracts in the separate repository, you need to have this repository and you need to configure all of the necessary stuff in order to actually automatically build this repository, automatically place contracts and these artifacts somewhere. In our case, it's Artifactory, but you need to once configure it and update it from time to time. And the main idea here, and the biggest challenge is communication. So contract testing, it's 95% relies on the communication between the teams, and only after that it actually the code and the tests. Because if some team makes a change in there, like which breaks integration with other services, and do not notify everyone about it, and deploy their change to production and breaks everything, it's a really flow of communication. It's not flow of technical stuff, it's not flow of the tools, it's communication. So the right question is it for me to use contract testing? So from my point of view, you don't, or you may not need to use contract testing if your communication between the teams are broken. Also, you want to substitute your functional tests with contracts. As I mentioned, contract tests should verify only the format of the messages or format of the request and response, not the functionality. Also, if you do not have unit tests, you do not, or the coverage, unit test coverage is very low, or you do not have a component tests for the service, you should start with this kind of testing and then switch to the contracts. And then if you think that contract testing is a fancy thing to try, I can agree if you want to try it only on your like pet project at home. But if we are talking about trying it or starting it for one of the product or for the whole company, it really takes time to actually implement it well and to get the results and get the benefits. So what I want to say in the end, the contract testing can bring the value, but the value will get really hard and not like immediately. And of course, if you are trying some new thing, you need to first think about whether it's needed, and also try a proof of concept. Try to implement. So in our case, we ran the proof of concept using Pact tool, using Spring Cloud contract, and we not only just implement actually the sample as it provided by the library owners, like the creators of these tools. So here is a sample, we need to re-implement it, and that's all. We tried to simulate the real flow of the usage inside of the development process. So what if the developer A will submit change without the contract test? What should, how the actually tool or library or the system should behave? So after you get this proof of concept and then you compare it for your defined criteria, you can choose which tool to use, or maybe which other technique or approach to use other than contract testing. So here it is for today. If you want to talk about any kind of testing or any kind of automation, not only contract testing, but contract testing as well, you can ping me in Twitter, or Skype, or LinkedIn, and just write me and I will answer, and I will provide a lot of resources, or try to get you to the point whether you needed contract tests or not. So this is also a time for your questions. Thank you for your attention.
Well done, Alex. Your presentation looks gorgeous. I really like it. And just the first question from my side before we move. As I understood, you have to invest a lot of effort in communication to set up all the things. In your company, how much time did you spend before you got some profit from this testing? Because as far as I understood, if only one team is using it, you will not see any change. So you have some like quality gate when this is accepted, but by most of teams, or how it works?
Thank you for the question. So basically, the first results, like for a couple of teams, so any change, it's not only contract testing, any change require the first thing is proof of concepts and comparison and choosing the tool and then implementing it for one or two teams. In our case, it's implementing for a couple of teams. So the first benefits and the showcase, we get like for maybe 3 or 4 months. It includes the research phase and the implementation of the real contracts phase. And then for the whole benefits of the contracts, it takes like a year and a half. And when the whole of the services inside our company have the contracts, maybe not 100% of coverage, but have the contracts and set up the flow, and they are following. So any new team that joins the company or any new product should follow these processes, contract test process. So it's year or year and a half. And of course, this all of this change requires, first of all, the work of the automation team. The second is work of the architects team, and then the R&D, like developers. So you need to show people the benefits, you need to provide the examples, you need to train a lot of people how to use it. So for developers, you need to provide training one, for QAs, you need to provide training two, and so on. So it requires a lot of work, but for now, I can say that it provides value in decreasing the tests with the same amount of quality level.
And also one question comes to my mind. Your examples are about some happy path when you have some list of entities from the server. So in case you have some error or you have some empty result, do you need to use the contract also to establish this, or it's another kind of testing?
Basically, it depends on what you need to test. So, for example, if you have functionality which depends on the format of the error message, so you have different, really different flows depending on the error messages or the content of the error. You can include also, you can define the contracts for the exception cases and create a contract tests for consumer and for producer. But in most cases, all of the exception, like exception cases or tests or error tests can be defined and can be tested only on the component level. So when you can define that inside of my test, I'm concentrating here on checking how my service will behave if other service call will not be successful, or how my service will behave if the call of the other service will be successful, but it takes a lot of time. For example, it takes like more than a timeout value. So we stick to that point, and also I have the same point of view that the exception cases, it's more suitable to test on the lower level tests when you have flexibility of defining these cases. Because basically, when you comes up with these exceptional cases, because if you are talking about testing, you always comes up with these exceptional cases. So you can actually you test actually the functionality, so how the system behaves with errors, but you are not testing the format of the message.
Do you use wire mock for such kind of scenarios, or how do you test negative?
For negative cases, of course, we are using wire mock for service virtualization and like Mockito and their implementation for Spring Boot. Also, it's not a different implementation. It's like different way of using Mockito using Spring Boot. So when you need to define external behavior for your components, for example. So it's basically WireMock. Yeah.
Got you. Any other questions? You can unmute yourself and just ask it.
One question. So thank you for your talk. And as far as I understand, there might be an issue with provider if a provider use.
Sorry, we don't hear you well.
Yeah. If provider use what?
As far as I understand, there might be an issue if provider use some kind of authentication. Yes. I have a question. Do you have such issues in your project, or maybe there is some common way to solve it in contract testing? I mean, when you
authentication between services.
Yes. Especially,
so,
for example, some dynamic tokens and so on.
Yeah. So basically, we are not in our contract test. We are not specifying and we are not testing this authentication flow inside the contracts. But when you define a contract, you can specify these tokens, and you can specify it not using hard-coded values like in tests. You specify it using regular expression. So, for example, you expect that one of the properties, query property parameters or header parameters, will contain this dynamically generated token. So you just need to know the data format of this token, and you provide that, hey, here I need to verify that the token should be type of long or type of some other type. And then inside the test, you are verify the format, and you are not caring about actually the value. Why it is? Because basically the testing authentication, it's a different kind of test. It's not format testing, it's functionality. But maybe in your particular product, the tokens and the authentication is a core part of your product that you need to test it. And so you need to implement a different kind of test for it. But if you are using just a third-party provider for authenticating, you just need to concentrate only on how your system should behave and rely more or less on the third party. So assume that the tokens will be correct.
Okay, thank you for the answer. Do we have other questions? Looks like no. So I really enjoyed your talk. Thank you very much, Alex, for joining us and share this experience. It was really cool. So I believe we can end this meeting now, and I will send all the materials later. Thank you very much.
Yeah, thank you all, and have a nice
See you.
evening or morning.
See you. Bye.
See you.
Thank
Bye.
you. Bye.